Hey everyone, let's graph some exponential functions. They're going to be the two that we covered in class on the other day when we introduced the notion of exponential curves. Right, the first is going to be p of x equals 2 to the 20x. Sorry, 2 to the 20x. Remember, this was the curve that modeled the population of a cell that's split every 20 minutes, right? Each cell splits every 20 minutes, so the population doubles every 20 minutes. So we're going to graph y equals, and now let's paste that guy in right there. And I say that, remember the basic shape of an exponential curve and use only function transformations. Right? Well, if we remember the basic shape of an exponential curve, let's say that this first guy right here is y equals 2 to the x. Right? Standard exponential curve, right? Low in the negative part, high in the positive part for x, right? Low in the, I guess you could say low in the second quadrant, high in the first quadrant, right? But if we're raising it to the 20x, that means we're compressing our graph, right? Because plugging in, let's say, plugging in x equals 0 still means that, it's 0. But plugging in, let's say, -1 means that you're plugging in -20 now. And plugging in 1 has the same effect as plugging in +20, right? So we're sort of down here. And really, this should be compressed 20 times as much. I'm not even doing it justice, but just to show you, the graph is very much compressed. Okay? So that's what that first graph looks like. All right, now the second graph, what is this? 17,000 times 1.05 to the x. Ignore the dollar signs, right? Right, now this curve, right, similar situation, right? We're going to start with a basic exponential curve. And then we'll transform it a little bit. So the graph 1.05 to the x looks similar to 2 to the x, right? Similar sort of shape. Maybe we'll start with red here. I guess the difference is that it's ever so slightly higher on the negative here. And then it does increase a bit slower. A little bit slower than 2 to the x, right? Because you're multiplying a lower number by itself. So it takes a while to increase. It does eventually increase without bound, but it takes a lot longer to do so. Okay? And now we're multiplying it by 17,000. Okay, well, I guess that means that, this stuff is stretched by a factor of 17,000. Right? So that means this isn't really comparable, right? This isn't exactly comparable. But the basic idea is that it's going to go like this. Like, this is certainly not to scale, but it's going to be doing something like that. Right? Because we're multiplying the final result by 17,000. Right? So this guy right here is y equals 1.05 to the x. This guy is y equals 17,000 times 1.05 to the x. Okay. So this is just basic, quick little graphing, how to graph the basic shape of an exponential function. This is what it looks like.